Good morning, good afternoon. A warm welcome to all our attendees today from across the globe. Thank you all for joining us today for this webinar on Planning Your Hadoop NoSQL Projects for 2011. We are delighted to have you with us for the next 40 minutes also as we discuss how these two game-changing technologies can help address all your big data challenges. I am Garima Arora from the Impetus marketing team, and I will serve as your facilitator for this session. Joining me today is Sanjay Sharma, Architect Big Data Technologies, and Gaurav Nigam from the Impetus Labs. We are going to discuss the challenges of moving to big data solutions such as Hadoop or NoSQL. We are going to discuss the requirement assessment and finding the right big data solution as per your needs. In our session today, we will also deliberate on planning for these solutions as an extension to your existing IT strategy or as a complete migration. Gaurav Nigam, who is our expert in big data technologies from Impetus Labs, will now take the session forward. Over to you, Gaurav.
Thanks, Garima. Before we move on to the details of this presentation, I would quickly give a brief overview of Hadoop and NoSQL. Apache Hadoop is an open source free software framework that supports data-intensive distributed applications. It enables applications to work with thousands of nodes and petabytes of data. Hadoop provides MapReduce APIs and works atop of Hadoop distributed file system. In computing, NoSQL, that is not only SQL, and No2SQL is a term used to designate database management system that differs from classical relational database management system and overcome their limitations with regards to scalability. These data stores may not require fixed table schemas and usually avoid join operations, and they can scale horizontally. They are meant to store high volumes of data. There are many such NoSQL databases available like HBase, Cassandra, MongoDB, etc. A common problem that we all face is identifying whether the project is the right candidate to apply Hadoop and NoSQL. Moreover, what is the cost benefit if we apply these technologies in our project? The purpose of this webinar is to help you decide if the big data technologies are the right solution for your business problem and discuss the challenges with implementation of projects involving big data technologies. We live in an electronic age and have an explosion of data stored in electronic format. Data is generated through many sources like social networking sites, stock exchanges, web servers, and many more such sources. The volume of data generated is very high and largely unstructured. Performing analysis or extracting meaningful information out of it's a cumbersome task. While Google's introduction of MapReduce has helped solve these problems in an efficient manner, but the adoption of these technologies is still a big challenge. Let us take a look at various challenges that we might encounter while adopting Hadoop and NoSQL. The first challenge is accessing whether Hadoop or NoSQL or the combination of both is actually required to address a challenge. If yes, then we will also have to figure out which among the various big data technologies will resolve the problem area in most effective manner. The next challenge is ensuring a smooth adoption of these technologies to benefit the various business needs, while keeping the risk factor negligible. The problem area also lies in keeping the adoption of Hadoop and NoSQL hassle-free and smooth and bypassing any potential hindrances. One of the very critical factors that we have to consider while adopting Hadoop and NoSQL is to ensure that these technologies get seamlessly aligned with our IT strategy. This will help avoid reinventing the wheel and enable us in utilizing our existing resources. Stay on, and we will help you find solutions that will address all these issues and challenges that you are facing in adopting these big data technologies. I would now like to know which is the biggest pain area in adoption of Hadoop NoSQL. Garima, can you roll out the poll, please?
Sure, Gaurav. The audience can now see the poll questions running on the screens. We want to know your biggest pain area in adopting Hadoop and NoSQL technologies. Your options are determining if Hadoop NoSQL is actually suitable for your application. The next option is lack of trained resources. The third option is aligning Hadoop and NoSQL with the current IT strategy. And the next option is any other reason, which we have not included. The time is up and we'll just collate the results. Gaurav, 32% of our audience are saying that their biggest pain area is determining if Hadoop and NoSQL will actually address their big data challenges. The second largest votes have gone to lack of trained resources. What is your take on this?
Thanks, Garima. As expected, most of our audience today find it difficult to determine whether Hadoop NoSQL is the right solution to their problem. Furthermore, doing a cost-benefit analysis for Hadoop and NoSQL is a challenge. I would request our audience to stay tuned to find out how we analyze Hadoop NoSQL as a viable solution to use in our big data projects. Let's talk about how we can plan for Hadoop and NoSQL projects. Implementing Hadoop NoSQL in projects require a defined technical strategy which ensures that any application really does require Hadoop or NoSQL. The implementation strategy can be divided into 3 phases. In first step that determines the criteria, we do a Hadoop fitment analysis. This is carried out to ensure whether Hadoop is actually needed in your project or not. Also, this analysis identifies which solution is best suited. Do we only need Hadoop or NoSQL? A combination of both. This can be validated through a POC. Once we are done with the fitment analysis, cost-benefit analysis need to be done. This includes analyzing deployment cost, operational cost, cost incurred in training the team to get in pace. We will discuss these topics in detail in our coming slides. Moving on to step 3, if the project meets the above 2 conditions, then it is the right candidate for applying Hadoop and NoSQL. We now need to look into its implementation and production readiness. We also need to address the challenges in deploying Hadoop NoSQL. We will go through each step in detail, starting with Hadoop NoSQL fitment analysis. This involves various challenges such as determining whether an application is eligible for Hadoop NoSQL. We have already discussed some of the challenges and problems which may help you decide whether Hadoop NoSQL suits your requirement or not. The other challenges with fitment analysis is R&D cost and the lack of suitable resources. Let me explain. It happens that the project is well suited for Hadoop and NoSQL, but the teams lack competency to deal with technologies like Hadoop or NoSQL. In such a scenario, building a team with suitable proficiencies in place is to implement Hadoop NoSQL can also be difficult.
Tell me something, Gaurav. The past year has seen an explosion in Hadoop and NoSQL adoption. And we do agree that the choice is pretty fantastic. Then why is there still so much of uncertainty around?
Okay, good. I believe that main reason of this uncertainty is due to multiple options available. There is always big concern, how do you choose a solution which will address your problem area most effectively? The selection of this solution is pragmatic decision and need to be taken with utmost care. I would suggest you to consider 3 points while choosing a NoSQL database. The first being scaling support. For example, HBase has been running in production environment across thousands of machines in cluster and managing petabytes of data, while MongoDB, CouchDB and other leading NoSQL databases, although much easier to set up and deploy, but not have seen such huge deployments. The next parameter is quality. Most of the time, quality is compromised for performance. The other factor you should consider is the community support and the people and the companies behind these projects, one of the very important factors. Sufficiently background study should be done before making a decision. You can Google and check if they have any videos, presentations, webcast available online. It will help much easier to figure out if these guys know what they are talking about. Among the other challenges, porting application on cloud is a big pain area. The cloud provide options such as Elastic Hadoop and ample disk space to store data on demand. Though it sounds obvious, The approach for solving these challenges is identify the symptoms and pain area, and an in-depth diagnosis of problem help understand and identify the right solution. You should also leverage the knowledge of experienced users and professionals for compute and data-intensive problems. Hadoop NoSQL have multiple viable solutions available. Let us now discuss how we can discover the best one for our requirement. Identifying the best fit solution is a real challenge. None among the available solutions are universal. This means that there is no single solution which caters to each and every problem. For example, the projects dealing with OLAP on large data can choose Hadoop or alternatives such as Pig or Hive. These solutions are best suited for teams who have expertise on a scripting language or SQL respectively. Pig and Hive both generate MapReduce job to answer OLAP queries and run on data stored on HDSS, that is Hadoop Distributed File System. Cost effectiveness is also a main challenge as the solution might cost more than expected. It is essential to gauge the actual implementation cost in the early stages so as to provide any unnecessary expenditure on research and analysis. Many a times, a solution to these problems come from experienced professionals and users. The early anticipation of costs that help adoption of new technologies pretty swiftly. However, sometimes the project owners are uncertain whether the problem is compute intensive or data intensive. If in case the problem is compute intensive, then there are numerous other options available other than Hadoop or NoSQL, such as grid solution like GridGain, Gigaspaces, or language like Erlang, CUDA, or NVIDIA. On other hand, if problem is due to data, then Hadoop NoSQL can be a suitable solution. Moving on to discuss how proof of concept can help. As we know, POC helps verify the viable options, and we can use it for Hadoop NoSQL also. As done in various other projects, POC will help you answer your queries with relevant facts and figures, such as whether the solution can be implemented or not, what are the technical challenges that you might face, how quick you can train your team, whether the solution is cost effective or not, or whether your application really requires a real-time solution or batch processing. POC will answer many more such questions than the one I mentioned, and you can address many technical challenges at this stage itself. And moreover, POC gives you a clear picture of cost effectiveness of a project as well as gauge whether the solution is production ready or not. The project costing includes parameters such as deployment cost, operational cost, and training cost. We will talk more about them in next few slides. We will start with deployment cost analysis. The various challenges involved in figuring deployment cost of Hadoop and NoSQL includes the cost involved in initial development and deployment, like figuring out how many Hadoop NoSQL servers are needed. In case if you are planning to host the application on cloud, you will need to analyze how much memory, CPU, or storage is needed for your application. We also need to determine if any specific hardware is required. Although Hadoop and NoSQL are designed to work on commodity hardware and cater your requirements easily, these issues can be addressed effectively with various tools available in market that helps analyzing cost of deployment on different cloud based on your requirements of RAM, CPU, and storage. Impetus has come up with deployment toolkit for Hadoop, which helps you create Hadoop instances on cloud and manage them. Lastly, having experts advice and following the best practices will help you enable solve most of your problems. After the deployment cost, we will now discuss the operational cost. The operational cost includes the expenses incurred for software, hardware, and maintenance cost every year or every month. This recurring cost also includes the expense on the team that provides support to the system configuration and processing. A thorough analysis of the solution is required to manage operational cost. The team must anticipate the future load based on history or intelligent forecasting. If the solution is deployed on cloud, then requisition of additional hardware, software can easily be made on demand. Otherwise, a prudent decision can be made to add or buy additional hardware for own data centers. Hardware resources may include dedicated and costly storage servers, routers, software like operating systems, and network bandwidth. The essence of this cost analysis is to estimate the impact on performance by resource reallocation change. Therefore, all the costs that is incurred to provide support and maintenance must be validated against benefits gained out of this expenditure. For example, time taken by Hadoop jobs is mostly directed dependent on number of machines in the cluster. This implies that a job which takes 10 hours can be reduced to 5 hours by doubling up the number of machines in the cluster. An appropriate business decision needs to validate whether reducing execution time is worth the added cost for extra machines. In our next slide, we are going to discuss the role that the training cost plays in adoption of Hadoop. But before I proceed, I would want you to know your opinion. Do you think it pays to bring in new resources with a desired competency? In this case, Hadoop NoSQL rather than train your existing resources. Garima, please roll out the poll.
Sure, Gaurav. The audience can now see the poll question running on the screen. We want to know if you think it is a better option to hire new employees with any desired skill sets. In the current context, we are talking about Hadoop and NoSQL rather than train your existing employees. Your options are yes, no, or maybe. The time is up and we are collecting the results. Gaurav, we have a balanced response. Around 50% among the audience are saying that they would want to bring in new resources, and the 50% they are saying that they would want to train their existing resources. What is your take on this?
Garima, I think I will discuss this in next coming slides. We all know that the competency of a team is most significant factor for implementation of these solutions. Since Hadoop NoSQL are emerging technologies and are specific to some special needs, hence the resources are limited. Hiring new resources and bringing them to a team understanding level is not an easy job, as it requires a lot of efforts in terms of time and money. Though training your current team to build their competency level might not be a cakewalk, but it is most sensible solution. As we are aware, Hadoop is MapReduce APIs in Java and is only a different programming paradigm rather than new technology to learn. I believe that training your development team to learn Hadoop with experts is the most viable option. The existing development team has domain knowledge which can be extended to new Hadoop module or new Hadoop project within the same account. Similarly, NoSQL is just a representation of data in non-normalized way. Understanding concepts of Hadoop NoSQL like column families and column may take some time but is not difficult to learn. For software testing engineers, testing Hadoop NoSQL is more or less similar to other systems. One word of caution though, the Hadoop based systems are meant for batch processing, not for real-time processing. Understanding Hadoop programming paradigm with development team would help in writing better test cases. Similarly, the testing team also need to understand the NoSQL databases. But as I said before, no specific training is required for testing team to test Hadoop NoSQL systems. Let me share with you why it is important for support team to understand Hadoop NoSQL deployment scenarios. As the operational team needs to work in tandem with developers to achieve best application performance, they do require appropriate training. This will help them address problems such as how many servers to deploy, how to cluster them, or how to tune them. For this, Cloudera provides specialized training for system admins. We have talked about cost involved. Let us now discuss the IT strategy to implement Hadoop NoSQL. One of the most rampant questions that we have came across is, can we use the traditional development approach for Hadoop NoSQL systems? My answer to is yes. Hadoop NoSQL requires no different approach in application development except understanding MapReduce programming paradigm. This programming paradigm helps you solve complex analysis on high volumes of unstructured data. It handles storage and analysis of petabytes of data and scales linearly with increasing volume. Development of Hadoop NoSQL application should be undertaken while using proven product development lifecycle.
I would like to share with our audience that within Impetus, we use a customary SPDMM or Software Product Development Maturity Model for software development. Our SPDMM has assisted us in the successful implementation of Hadoop and NoSQL projects. SPDMM is an initiative by Impetus to provide a significant source and standard for software product development. Our maturity model enabled software product development cycle will ensure that almost all the critical architectural, non-functional, and development time nuances are identified. Using these proven standards guarantees quality product development.
To add what Garima shared with you, along with SPDMM, we have also used best practices, tools like continuous integration, TDD, Sonar-based code reporting for most of our Hadoop NoSQL projects. We will now talk about the production readiness in deployment of Hadoop NoSQL systems. This, ladies and gentlemen, is the most significant part in product lifecycle. Unit testing of MR jobs and integration testing should be considered before moving on to production. Integration of Hadoop with other parts of application is very important, often a point of failure. Hadoop systems are basically meant for batch processing, and results of MR jobs are used in real-time processing. We also need to provide a reasonable time to Hadoop for retrieving correct results. These constraints must be taken in account while integrating Hadoop with real-time systems. The NoSQL databases, on the other hand, are basically meant to store large volumes of data and provide high fault tolerance. These databases are good when they are more read operations than write operations. Production environment need proper tuning for optimized performance, and this is true for Hadoop and NoSQL. Moreover, proper partitioning of map results based on prior knowledge of data helps in improving throughput. Utilizing of existing maps may improve performance, as the time for bootstrapping a new JVM for a map may cost a bit. Hadoop has a sub-project called Mahad, which can be used for machine learning based analytics and can be leveraged to reuse its capabilities than building solution from scratch. NoSQL databases have many tuning parameters like using separate IO device for commit log, concurrent writers, etc., which can be used to optimize performance. There are many more such parameters that can be used to optimize performance. We need to take special care in configuring these parameters and take help from experts to tune them. As discussed earlier, we need to have a specially trained deployment and support team who can take care of these deployment and configuration. Minor changes in configuration parameters can seriously affect application performance. Therefore, we need to be very vigilant while doing these deployments. This, ladies and gentlemen, is our failure-proof way to adopt Hadoop and NoSQL technologies. But won't it be an icing on the cake if there is seamless and hassle-free way of aligning the big data technologies in your existing IT setup? My colleague Sanjay will tell you how you can avoid reinventing the wheel. Over to you, Sanjay.
Thanks, Gaurav. I will now discuss the impact of moving to Hadoop NoSQL technologies on the overall IT strategy. We'll begin with data warehousing. Hadoop provides altogether new approach to the traditional data warehousing concept. With inbuilt support for redundancy and failover, as well as distinct analytics interfaces, database team needs to realign with Hadoop data warehousing concepts. For example, tape backup strategies usually go for a toss, and similarly, traditional processes usually seem to lose relevance with Hadoop-based data warehouse. NoSQL databases too have their own integration or backup strategies with traditional or Hadoop-based data warehouses. In continuation to the data warehouse's impact, enterprise architecture also may require alignment with the centralized data warehouse across organization units and products. Instead of siloed data marts or data warehouses, a Hadoop central data warehouse would enable data marts like views to be built over it. The network and infra team has to be aligned to horizontal scaling rather than vertical scaling. They have to understand the nuances and challenges involved in handling and managing large clusters of Hadoop NoSQL solutions. Since these technologies are relatively new, the lack of sufficient utilities and tools certainly is a big challenge for the infrastructure teams. We will now discuss about the impact on development teams. The biggest challenge for a developer is to start thinking in terms of large data sets which has its own unique challenges. MapReduce is a simple algorithm, but converting business algorithms and problems is still a daunting task. Similarly, usual lack of SQL and database relationships forces database developers to rethink database design strategies when dealing with NoSQL databases. The testing team, if not already aware of large data testing, also needs to start thinking about testing at scale. Moving over to discuss the impact of Hadoop NoSQL on BI and analytics. The big data technologies offer different ways of deeper analytics. However, the traditional silver bullet SQL-based tools do not usually seem to work here. While the Hadoop world has Hive or Pig or the MapReduce programming model to fall back on, open source NoSQL databases usually require altogether new approaches due to lack of capable tools. Now the business strategy. Interestingly, Hadoop NoSQL unearthed new ways of finding business value from the deep ocean of data which could not be used earlier. New business ideas can evolve out as well as help in growing the existing business ideas. For example, better recommendation engines or ability to easily support huge consumer base for a website can spawn multiple profit-making business ideas. I will now share with you the changes you need to make to your IT strategy to incorporate Hadoop and NoSQL. We believe that it is possible to make use of the existing investments when migrating to Hadoop and NoSQL technologies. Hadoop MapReduce framework allows to reuse most of the business logic. Most of the existing Java or C++ or Python code can be reused after aligning it with MapReduce programming pattern. For example, we were successful in reusing large portions of legacy C++ code in new Hadoop MapReduce jobs for one of our customers. Additionally, Hive will allow us to reuse some of the SQL-based business logic. NoSQL databases, on the other hand, can be retrofitted in some of the existing applications using data abstraction layers such as an ORM, Object Relation Mapping tool. However, a word of caution here. NoSQL does not like database relationships and would eventually run into performance problems if the data is too normalized. Impetus has open sourced an ORM tool called Kundera, which can save a lot of effort on using NoSQL databases like Cassandra or HBase. This is very much like Hibernate in Java or Active Records in Ruby, which allow developers to focus on entity modeling rather than writing raw database interactions. The impact on development as well as build and release management is minimal, since most of the existing tools and processes can be reused. Best software practices such as continuous integration, test-driven development, or automated testing can easily be continued to be used without any modifications. Data warehousing, storage, and archival usually require migration to the new platform. BI analytics tools can be reused in most cases, but sometimes there might be requirements for overhauling the existing reporting tools. The primary reason behind that is that most traditional reporting tools use in-memory handling, which becomes impractical when dealing with large data sets. I would recommend all to have a look at a past webinar on analytics on large data to further deep dive into this topic. The recording of this webinar is available in the archive section of our website. So here is the recap of everything discussed so far. Hadoop NoSQL systems are simple, but their learning curve can be steep. Hadoop is MapReduce APIs over a scalable distributed file system and is a different programming paradigm to learn. MapReduce programming paradigm is analogous to any SQL query. Select part of a query is analogous to map function, and while clauses attached with a query like group by are equivalent to reduce functions. NoSQL databases can be considered as data stored in single table with redundancy. This saves costly join operations. Hadoop NoSQL does not require any costly or complex implementation process. Rather, it can be just an extension to the current IT implementation strategy. Any painful module can easily be migrated on Hadoop. Most of the times, existing code can be reused rather than writing code from scratch. Testing strategy might change a bit, but does not require a 180-degree change. The only aspect that needs to be taken care is that Hadoop systems are meant for batch processing. NoSQL databases can be integrated with any application like a normal RDBMS and does not require major change in testing strategy. With trained team on Hadoop, you can quickly set up development, test and production environments. The large effort is only in writing few deployment scripts which can be used again. We at Impetus have been delivering big data projects successfully for the last 2-3 years. Our proven big data solution methodologies, processes and tools help in accelerating development and production deployment of Hadoop NoSQL solutions. Let us now look at some real-world examples. The first case study that we are going to discuss today is of one of our clients, a leader in global internet services and media. Under pressure to sustain and grow in the competitive online advertising and media market, there was a push from top management to start using Hadoop. Various product teams inside the company started experimenting with Hadoop, and soon there were silos of Hadoop-centered products running with increasing problems of low return on investment on Hadoop infrastructure. Development teams were soon facing issues with writing correct Hadoop analytics jobs as well as Hadoop performance and optimization issues. The enterprise architecture team could clearly sense that the promised centralized data warehouse view was missing. Impetus engagement started with looking at the bigger enterprise strategy and assessing the products that could be benefited with Hadoop NoSQL technologies. Not all business products could be benefited, as we clearly saw that some of the products did not require using Hadoop or NoSQL technologies. For example, standalone, low latency, low volume, RDBMS based products did not require migration to NoSQL databases. Similarly, we recommended replacing low latency read-write Hadoop usage with NoSQL or other simpler solutions, and then bridging or piping the data to the Hadoop clusters to build a big central enterprise data warehouse. We also recommended not replacing existing traditional ETL jobs, since the volumes for this particular product was not high and slower ETL was easily managing the required SLAs. We, however, modified the Clover ETL flow to use HDFS as the data sink. Moving on to our other case study, we'll talk about a large enterprise product targeting an enormous user base in US with data sizes of terabytes and petabytes. The initial product was designed to be built on Microsoft technologies and deployed on cloud, which did not work out well for the client. The product owner soon realized that the traditional solutions could not match the required data sizes or the SLAs after the first performance test cycle. Impetus started with a 4-week architectural consultancy to come up with a large-scale solution after review of the business requirements as well as non-functional requirements. Impetus used its proven SPDMM methodology to validate non-functional requirements and proposed a Java-based solution based on a leading NoSQL database for managing huge amount of data. The next stage involved micro-benchmarking the various technology stack components to prove the validity of the proposed solution from the non-functional requirement perspective. Major decisions of interest in the solution were whether to use traditional RDBMS along with the NoSQL database, as well as how to simplify development and usage of the NoSQL database. The initial decision to reuse some of the existing RDBMS was soon reverted as it was costlier to manage the data replication between NoSQL and RDBMS solution, and it was much easier to build the solution using NoSQL only. Impetus built an ORM layer for abstracting the difficulties with database schema design. Impetus also built utility tools such as UI browser over the NoSQL database to speed up development and testing. I will now invite you to send across your big data requirements to us. We'll select a few for free POC and free consultation.
Thanks, Sanjay. Hadoop and NoSQL implementations are growing at a fast-paced rate. The big data technologies are helping enterprises across the globe deal with colossal amounts of data and have already made a deep impact on some very prominent organizations. I hope the session today was a learning experience for you. This webinar was hosted by Impetus Technologies. We offer product engineering and technology R&D services for software product development. We partner with our client base comprising large-scale ISVs and technology innovators to deliver cutting-edge software products. Our expertise spans the domains of large data management, cloud computing, data analytics, mobile, SaaS, testing, performance engineering, among others. Impetus has a strong focus and established thought leadership in the area of large data analytics and high-performance computing. We have built top-tier expertise and offer consulting and professional services in big data technologies. So moving on to the questions we have received from our audience today. Gaurav and Sanjay, the first question is how to decide which NoSQL database to select among HBase, Cassandra, MongoDB, Riak, etc.
Sure, I'll take that up. So, choosing the right open source NoSQL database is certainly a painful task. As some of you might be aware, the current NoSQL databases can be broadly classified into column family oriented, document oriented, graph oriented, and simple key value oriented databases. Please note that there is no universal fit all NoSQL database to solve all business use cases, unlike what RDBMS has been used for last 20 years. The leading column family databases, HBase and Cassandra, offer huge scalability, whereas document-oriented databases are more flexible and developer-friendly, but cannot compete with column family databases in sheer volume sizes. Graph databases fit better for social graphs and media software or any business use case involving nodes, edges, and properties to represent and store information. Key value pair databases like Riak, SimpleDB, etc. offer only simple data to be stored but can scale to huge volume sizes. To summarize, specific NoSQL databases solve specific business problems. So it is very important to analyze the business use case and then decide on the best fit NoSQL database. Garima, can we take up the next question, please?
Yeah, sure. The next question goes like, can we leverage cloud platform for Hadoop and NoSQL systems?
Garima, I would like to take this question. First of all, I would say that's a nice question. Hadoop applications are basically meant for batch processing, and these applications require a lot of processing power, memory, and storage. procuring a dedicated infrastructure for Hadoop may not be a cost-effective solution for most of the organizations. Rather, we can go to rent these infrastructure on cloud based on your demand. And once you do the Hadoop batch processing, you can relinquish these services. So you only pay for what you have worked with. Means you pay only for the time you have used the infrastructure. Also, I would like you to know that Amazon provide elastic MapReduce, using which you can instantly provision as much or as little capacity you want for doing these data intensive tasks. It also lets you focus on crunching or analyzing your data without having to worry about time-consuming setup or doing some management activities or tuning Hadoop clusters. I think this answers your question.
Thanks, Gaurav. Thank you all for joining us today. We are going to bring our session to a close now. We hope that this discussion was a learning experience for you all and will add value to your Hadoop and NoSQL project planning for this year. If you have any questions, please email us at inquiry@impetus.com or visit our website www.impetus.com. I would like to inform you that we will take up the questions that we have received over email. We also invite you to send across your big data requirements. We will make a selection and offer free POC to a select few. I would also like to inform our audience that we will be at the TDWI Las Vegas from February 13th to 18th. If you are interested to meet up with us over there, drop us a mail and we will get back to you. Thank you once again. Have a good day. Bye-bye.